The immense scale of ancient Mesopotamian states was defined by their massive agricultural estates and highly engineered canal systems. The durability of these early states relied on standardized administrative control over local resources and human labor. That sprawling geographic control was executed on a microscopic level. Administrators managed the daily logistics of the state by pressing data into small, wet clay. To understand how this system functioned, we look to physical artifacts recovered from the royal cemetery area of the ancient city of Ur. Archaeologists excavating deep layers known as the seal impression strata, specifically levels 8 through 4, uncovered thousands of broken clay lumps. These clay fragments functioned as physical locks, designed to secure the state's supply chain against tampering or theft. By analyzing the physical properties of these fragments, we reverse engineer the operational nodes of the earliest imperial bureaucracies. The central problem in studying these economies is that the vast majority of Mesopotamian wealth consisted of organic materials. The grain, oil, textiles, and leather have long since rotted away. This leaves archaeologists searching for the structures of highly integrated bureaucracies within layers of dirt where the actual commodities and daily ledgers no longer exist. The solution involves deconstructing the inorganic administrative tools left behind, the hardened clay ceilings and the stone cylinder seals used to stamp them. We track this control through two distinct lines of evidence. First, we examine the physical geometry of those jar ceilings from Ur. Second, we analyze the diachronic, or time-spanning, modifications carved into the stone cylinder seals themselves. By studying the negative space preserved inside broken clay and the updated cuneiform texts on stone, we reveal the invisible mechanics of ancient state power. Research conducted by archaeologist Richard Zettler on Ur's seal impression strata provides a mechanical blueprint for this security system. Zettler's methodology involves pressing latex against the reverse side of the broken clay lumps. This process creates a positive cast of the exact object that the clay originally secured. The casts reveal a highly specific security protocol. First, leather or cloth was stretched tightly over a storage jar's mouth. Next, a cord was wrapped tightly around the neck to secure the covering, finishing in a prominent knot. Wet clay was then pressed directly against the jar's shoulder and neck. The clay completely swallowed the knot, forming a precise, tamper-evident physical seal. Finally, an administrator rolled a carved cylinder seal across the wet clay. This embedded a complex, high-relief institutional signature into the surface, rendering the lock unique and mathematically difficult to forge. This specific, repeatable sealing method proves the existence of strict institutional security protocols governing the movement and storage of state goods. This need for identical sealing surfaces and predictable storage volumes forced changes across the manufacturing sector. To supply an increasingly efficient distribution system, local potters adopted economizing measures that led directly to mass standardization of their wares. The primary archaeological indicator of this shift is the solid-footed goblet. These vessels appear in the archaeological record with absolute uniformity in their rim and neck dimensions. This exactness prioritized logistical trackability over individual artistic expression or functional variety. Craft specialization in early Mesopotamia was a byproduct of a state that demanded measurable, interchangeable units to maintain its trade networks. While the clay ceilings were disposable, the cylinder seals themselves were permanent tools of the bureaucracy carved from stone. Assyriologist Robert Biggs identified a specific hematite cylinder seal that bears physical evidence of being recut and updated centuries after its original creation. The seal presents a distinct anomaly. It features a classic Old Babylonian visual motif, but is inscribed with a Sumerian prayer typical of the much later Kassite period, a dynasty that ruled Babylon hundreds of years afterward. Physical evidence proves the text is a later addition. The central perforation hole of the seal was shifted off-center to accommodate the depth of the new inscription. Furthermore, an engraved line that once formed the bottom border of the original Old Babylonian scene was ground away and obliterated to make room for the new text box. The new text is a prayer to Utu, the Sumerian sun god. It is written using specific shorthand cuneiform signs, like a defective dim 4 character, that are distinctly characteristic of later Kassite administrative scribes. Later administrators physically overwrote the past, repurposing ancient tools to graft historical legitimacy onto their contemporary systems of control. This granular forensic data scales up to solve macro-historical problems, specifically the challenge of absolute chronology, the attempt to synchronize the independent timelines of different ancient superpowers. A central anchor in this effort is determining the exact destruction date of Level 7 at Alalak, an ancient city in the Levant. Archaeologists use glyptic evidence, specifically the seal impressions of local rulers like King Yeramlim, to establish a direct synchronism between Alalak and the reign of Hammurabi in Babylon. Ceramic assemblages provide the parameters. The presence of specific painted wares, namely habor and bichrome pottery, act as physical constraints that narrow down the timeline theories for the city's destruction. The macro history of these empires is held together by the precise synchronization of these standardized pots and verified seal impressions. When we look at the geometric footprint of ancient Mesopotamian cities, we look at a landscape managed entirely by the artifacts we have just deconstructed. Coordinating massive labor projects like canal dredging and agricultural distribution required a memory system that transcended the lifespan of individual human beings. It required the institutional archive. The organic wealth that fueled these empires was inherently fragile, but the administrative tools designed to track it were permanent. The grain was consumed, the textiles decayed, and the city walls eventually eroded. Yet the data of the bureaucracy, pressed into clay and carved into stone, remained in the earth. The clay held its exact shape, preserving the precise logic of institutional control long after the institutions themselves collapsed. The enduring legacy of the ancient Near East lies in the invention of verifiable data management, the administrative mechanics that made civilization at scale possible.